What's up, mathletes? This is section 2.1, solving linear equations and inequalities. Let's kick it off. We got example 1. Solve that nasty looking equation. Wow. Okay, I see basically three terms. The ones on the left-hand side have a fraction. Fractions always make things way more complicated than they need to be, so let's clear the fraction as a first step. Least common denominator is 3, so you can multiply all three terms by 3. And when you do that, you cancel out the fractions here, and then of course negative 4 times 3 is 12. Way simpler to do. You could, if you wanted to, distribute and you get 2/3 x minus all that. Then you get a 1/3 x. You'd still have fractions over here. So I just think it's way easier to, as a first step, clear the fraction, or even clear the decimal if you got one of those, by multiplying it by something that will clear the fraction. Then all of this term, this is one term right here, times 3. This is another term, times 3. Gives you this. 3 times 1/3 cancels, gives you 1. And so then you have 2x minus 57 plus 6x minus x equals negative 12. You don't need the parentheses anymore, and then when you combine like terms, you get x minus 51 is equal to negative 12, and x is equal to 39. Now, generally in my class, you're not required to check your answers, but I do recommend it in a testing situation if I'm giving you a quiz. And it's interesting to look at. If you have the solution, you should be able to put it back in for x, and it should check out. The entire equation should be a true statement, and it is. Let's take a look. Interesting fun fact. If you have an equation that's true, you should be able to multiply all the terms on both sides by a particular number, like 10 in this case. 1 plus 2 plus 3 equals 6, and then if you multiply all the terms on both sides by 10, you get 10 plus 20 plus 30 equals 60. And that's also a true statement. And so we're going to be, we use that here, I'll multiply all the terms on both sides, and we're going to be using it a lot. All right, example number 2. This is a word problem, and word problems are always really difficult, but we've got something that helps mitigate that and make it a bit easier. It's called knowns and unknowns. It's actually very similar to what the 5-step process from physics that you might remember from last year. You don't actually have to write out the full word known or unknown. Maybe you could just mark it with a K and a U, but it is required in my class, and check to make sure that you do it in your comp book when you get to your Alex problems. Example 2, the diameter of Earth is 828 kilometers less than twice the diameter of Mars. If Earth has a diameter of 12,756 kilometers, what is the diameter of Mars? Well, first thing you can do is write down the things that you know. We know it's 828 kilometers, and we know, it's less than twice the diameter of Mars. That's the first number you can write down. Then the diameter of Earth, we'll call that E, is 12,756 kilometers. Then what you really have to do is you also have to write down the thing you don't know, the thing you're trying to find, what you're trying to solve for. The diameter, and you can see it's right here in the question. This is the easiest part of the whole process, but it's the part that students forget to do most frequently. Find the thing you don't know, and it's right here in the question. You look for the question mark. Boom, diameter of Mars. That's the thing we don't know. Choose a letter from the alphabet. M. Doesn't have to be M, could be some other letter if you want, but you've got to choose the letter from the alphabet to represent the thing you don't know. If you don't do this, then it's going to be impossible to write the equation. You can't write an equation you should solve for if you don't have a variable letter. Choose a letter from the alphabet. Incredibly important. That's the thing you don't know. Then you have to relate them all into some sort of equation. And in this case, 828 kilometers less than is the subtraction, and then twice the diameter of Mars, 2m. That's the diameter of Earth. Earth is 828 kilometers less than 2 times Mars. Boom. And then I also know what Earth is, so I can fill that in as well. So then I get that is equal to that. Let's add 828 to both sides, and then divide by 2, and that's what you get. That is the diameter of Mars in kilometers. Oh, it's also very important to label these things as with their units. It helps out incredibly to tell a story. And if you ever need to change units, then it'll tell you. It's a lot easier to see. Okay, so example 3. The formula for the perimeter of a parallelogram is P equals 2a plus 2b, where a and b represent the measures of the bases. Solve the equation for b. Now, there's actually lots of different ways of doing this. I'm listing out two here. So if you ever are worried about getting the exact right equation, there's actually there's like a couple right answers. So depending on how you do it. So fortunately, Alex.com will recognize all valid ways of finding all valid answers. Okay, so you can see we're going to start out with the same formula, and then our goal is to get b all by itself. So you can undo the subtraction here, subtract by 2a, and you get p minus 2a is equal to 2b. Then if our goal is to get b all by itself, then the last thing to do is undo the multiplication with division, and there it is, p minus 2a all divided by 2. The entire left-hand side needs to get divided by 2. Another thing you can do, just like the fun fact I said over here, like 1 plus 2 plus 3 equals 6, you can multiply all the terms on both sides by 10. Well, you can also divide all the terms on both sides by a number. If you do that, you get p over 2 is equal to a plus b. The motivation for that is to get rid of this 2 right here, but it's also kind of convenient because it would also cancel out this 2. Anyway, p over 2 is equal to a plus b. And then you can just undo the addition with subtraction, p over 2 minus a equals b. And so these two answers are equivalent to each other. The same, mathematically, they represent the same idea. They still are, they're rearranged perimeter of a parallelogram, but they're just expressed differently. All right. Next, solve by graphing. Use your Inspire. So, if your goal is to try and figure out what x could be, then what you can do is you can actually cut this in half and just put this part, x cubed plus 3x minus 2, into your Inspire. Oops, sorry, this should be a 2 right here. I'll fix it later. It'll be a 2 in your packet. Okay, so then f of x is equal to x cubed plus 3x minus 2. You can see right here, when is this function going to equal 0? When is all of this going to equal 0? That's the question we're looking for, and you can graph it. So if you, in your parabola, you can see right here, the x-intercepts are actually going to be the values of x that make this all equal to 0. And that's actually what's called as a 0 of a function. Any input value of a function that produces an output of 0, which in this on a graph would actually be the x-intercept. So finding x-intercepts are incredibly important. The 0 of a function is a number. So the 0.562 is a 0. Negative 3.562 is a 0 of the function. This function right here, if you take either of those two numbers and put it in for x, calculate it out, you'll get 0 as the answer. More or less, because we rounded. Now would be a good time to talk about the audio check. The question is, what is my wife? Or like, what is her job? What is my wife? She's a wonderful lady, and she's also a hospice chaplain. She goes from home to home, talking to dying people and their families and helping them process the difficult times ahead. Wow. Hospice chaplain. She's pretty awesome. The Empire State Building run-up race is a race in which the athletes run up the building's 1,576 stairs. In 2003, Paul Craik set the record for the fastest time, running up an average of about 165 stairs per minute. What is the relationship between time and Paul's steps remaining until he gets to the top? Express this as an equation, table, and a graph. All right, well, let's take a look at knowns and unknowns. What do we know? 1,576 stairs. What's the rate? 165 stairs per minute. Unknowns. It's actually critically important that you analyze or you examine or think to yourself, what are the things we don't know? What are the variables going to be here that we have to relate? Especially if we're going to make an equation table and graph, I think what that means is we need two variables that are going to relate to each other. The two variables are going to be time and the steps remaining. So, and that we get that from the question right here. What is the relationship between time and steps remaining? choosing letters from the alphabet, very important. I'm going to let t equal time and r be steps remaining. So you can see here's the table, t and r. And just to think about it a little bit, if 0 time has elapsed at the very beginning of the race, still has 1576 stairs to go. But after 1 minute, he should have at this average rate, he should have gone 165 stairs. So we can subtract that out and get what the new how many steps are remaining now. After 1 minute, he still has 1411 steps to go. After 2 minutes, that's 165 times 2, and then you subtract from the original, and that's how much he has left. After 3 minutes, and so I think what we can see here is the slope is going to be 165, and that should not be a surprise to us because this is a rate. How quickly is it going? 165 stairs per minute. So the rate is equal to 1576 minus 165 times t. And if you plot these points here, you can see this is what the graph looks like. At 0 time, he still has 1,576 steps to go. And then as time elapses, he has fewer and fewer steps. Until eventually, he has 0 steps remaining after about 9.5 minutes. Boom. All right. Next. Solve. Okay, this is an inequality. So you can copy inequality here. It says graph the solution set on a number line. Well, here we go. We got negative 5.6 n plus 12.9 is greater than or equal to negative 71.11. You can solve it exactly the same way you would as an equation. You can see you have to undo the addition with subtraction, subtracting 12.9 from both sides. You get that. And then divide both sides, undo the multiplication by dividing to get negative 5.6 over to the other side. Negative 84 divided by negative 5.6 is going to be, and you can do this on the calculator, or you can read it from the inequality here that I've graphed. In any case, one thing that I do want to see here, or I do want to say, very important, is that you notice this is a greater than or equal to symbol here, but then down here it's a less than or equal to symbol. When you multiply or divide an inequality by a negative number, you have to flip the signs. That's the rule. Anytime you multiply or divide by a negative number, you have to flip the sign. So anyway, this is the boundary point is 15, and you can see 14. Oh, so I have to shade one of the sides. I have to shade it, and one really fun fact, maybe a quick mnemonic device to figure out which way you shade. If you have the variable and then the symbol and then the number in that order, not like not the number over here and the variable over here, but if the variable on the left, then you can look at this symbol right here, and then that's the arrow that has to get shaded. You see, this almost looks like the same kind of arrow that gets shaded to the left. So n is less than or equal to 15, and you see that 14 also works, and 13 works, and 0 works, and all those numbers works. One thing that I do want to say is that if you have an open dot, you should use an open dot whenever you have just a less than symbol or a greater than symbol, and you should use a closed dot like this whenever there's a less than or equal to symbol or a greater than or equal to symbol. Example 7. Recommended daily intake of calcium for teens is 1,300 milligrams. Jake gets 237 milligrams of calcium from a multivitamin he takes each morning and 302 milligrams from each glass of skim milk that he drinks. If he drank 1 glass of milk, would that be enough? Or maybe he needs 2 glasses, or 3 glasses, or 10 glasses, or 100 glasses. Which numbers of glasses would be enough? Let's go knowns and unknowns, because it's a word problem, and it's good to do, it's a great habit to be in, and it's also required in my class when you get to alex.com word problems. Okay, so knowns. What do we know? He's got this multivitamin he takes every morning, 237 milligrams. He also knows that every glass of milk that he drinks, he can also get 302 milligrams of calcium. What don't we know we don't know how many glasses of milk he's going to drink. So let's give the variable m, let's assign the letter of the alphabet m to the thing we don't know. And we don't know it because we looked at the question. Which numbers of glasses of milk would be enough? Glasses of milk is a thing we don't know, so we'll let that be m. Oh, we also need to know that there are 1,300 milligrams of calcium daily. That's at least. It's okay to get more. So you can set that up like this. You're relating all the things you know and don't know like this. This is the multivitamin, 237, and this is the glass of milk, 302. And you can multiply that by the unknown, the thing we don't know how many glasses of milk. And at the very least, it should get 1,300. More is okay. So 1,400 is great. 1,500 would be fine. But 1,200 would not be good. And 1,300 would be okay also. 1,300 is the boundary point, and if you somehow got exactly 1,300 milligrams of calcium, that would be fine. So the boundary point should be included. All right, so solving this, subtract 237 from both sides, dividing both sides by 302, and rounding it, you get about, needs like 3.5 glasses of milk every day. All right, that's it. Thanks for playing along, folks. It's been wonderful. I will see you in class. Take care.